So we're going to take a look at a patterns question involving graphs from the Junior Cert Higher Level 2012 Paper 1. So it's question 7, and the first part of the question tells us that Lisa is on a particular payment plan called Plan A for her electricity. She pays a standing charge each month even if no electricity is used. She also pays a rate per unit used. The table shows the cost, including the standing charge, of using different amounts of units in a month. So we can read the table easily enough here. When she uses 100 units, her plan, including the standing charge, is 38. When she uses 300 units, it's 74. When she uses 600 units, it's 128. So all of these amounts in euros on the right hand side, they include the standing charge. The question asks us to use the data in the table to show that the relationship between the number of units used and the cost is linear. So a linear relationship is one where the difference is the same each time. And so if we calculate the differences between the costs of electricity every 100 units used, we can see that the difference is 18. And so the relationship between the number of units used and the cost of our electricity is linear. We have to be a little bit careful here going forward in the question. For every 100 units used, the electricity bill increases by 18 euros. But for every 1 unit used, this is only an increase of 18 divided by 100, which is 0.18, 18 cent. So just something to be aware of as we go forward in the question. So equally, we could have said that the relationship is linear because each additional unit goes up by the same amount, 0.18. The B part of the question then asks us to draw a graph to show this relationship between the number of units used and the cost of electricity. Generally, when we're using a table like this with a left column and a right column, the left-hand side goes on the bottom of our graph. So the units used is going to go on the bottom. It increases in intervals of 100 all the way up to 800. On the side then we have the cost in euro going from 0 up in tens until we get to 150 up here. And above that 160, 170, which aren't labelled. So we're going to fill dots onto the graph to represent the information on the table. So for 100 units used, the cost is 38 euros. So 10, 20, 30, 40, so a little under the 40. For 200 it's 56, so 10, 20, 30, 40, 50, 60, so a little more than halfway between 50 and 60. And so on, 374, 492, 500, 110, 600, 128, 700, 146, and 800, 164. The relationship is linear, so we draw a straight line through all these points. So the C part of the question says to use the graph to estimate the standing charge. So the standing charge is the charge even if no electricity is used. And we can see on the graph by extending the line back into where it cuts the y-axis, we can see that the cost is 20 euros at 0 units of electricity used. And so the standing charge is 20 euros. Part D then asks us to write down a different method of finding the standing charge. So we're looking for the cost of the bill when 0 units are used. We can see that the difference between each 100 units is 18 euros. And so if we just subtract 18 euros from 38, we'll get the standing charge of 20 euros. Part E asks us to write down a formula to represent the relationship between the number of units used and the cost for any given number of units. So we're trying to create a formula that will tell us the cost of electricity if we input the number of units used. So what we want to calculate first is the additional cost per 1 unit extra used in electricity. We know that every 100 units used costs an additional 18 euros. And so we already established that for every 1 unit used, there's an additional cost of 18 divided by 100, which is 18 cent or 0.18 euros. To create a formula for the cost of electricity, we can write down that the cost will be equal to the standing charge plus 18 cent for every unit of electricity used, and we'll call the units of electricity X. Make sure to write down what the letters stand for. So C stands for the cost of electricity, and X stands for the number of units used. So we're multiplying by the additional cost for each unit used, by the number of units, and then we're adding the standing charge. And this will give us the cost of the electricity. To look at a slightly more formal approach, we're going to use the slope of the line to calculate the rate of change of the cost per unit used. So the slope is equal to the rise over the run. If we select 2 points on the graph, we can see that the rise is 18 when the run is 100. So the slope is equal to 18 over 100, which is 0.18. And so we can see that for each one additional unit used, there's an increase in the cost of 0.18. So creating our formula, we're going to multiply 0.18 by x, the number of units used. That will give us the charge for the amount of electricity we're using. And then we're going to add 20 for the standing charge. And so C is equal to 0.18x plus 20, where C is the cost of electricity and x is the number of units used. Part F tells us that the table does not include VAT. 1 month, Lisa used 650 units. Her total bill for that month, including VAT, was 155.50. So we have to find the VAT rate on electricity correct to 1 decimal place. So to calculate a VAT rate, we take the VAT and divide it by the bill before VAT, and we multiply it by 100. So we're going to need to find the bill before VAT and the VAT. And so what we're going to do is we're going to use the formula we created to find the bill before VAT. We'll subtract this from 155.50 to calculate the VAT. So 650 units isn't a number on our table, and so if we take our formula that the cost is equal to 20 plus 0.18x, we sub 650 in for x, the number of units used, we multiply it by 0.18 and add it to the 20, and we get that the cost, the price of the bill before VAT for 650 units is 137 euros. So we're going to take the 155.50, the total bill for the month including the VAT, I'm going to subtract 137 euros, the price of the bill before VAT, and that will give us a VAT value of 18 euros and 50 cents. If we come back up to our formula and we sub 18.50 in for the VAT and 137 euros in for the bill before VAT and multiply it by 100 to turn it into a percentage, we get that the VAT rate is 13.5%. The G part of the question says that Lisa is offered a new plan, Plan B, where the standing charge is 36 euros and the rate per unit used is 15.5 cents. The first thing we'll notice is that the standing charge, 36 euros, is a good bit more than the standing charge of Plan A, which was 20 euros. But that the rate per unit used of electricity is 15.5 cents, which is less than the 18 cents on Plan A. The first thing we need to do is we need to calculate the increased cost per 100 units used, rather than 1 unit. 1 unit is 15.5 cents, but for every 100 units used, it's 1,550 cents, and we'll convert that to euros so that we can add it to the standing charge. So for every 100 units used, there's an additional cost of 15 euros and 50 cents. So the standing charge when 0 units are used is 36 euros, and the cost when 100 units is used is going to be 15 euros and 50 cents more than this, 51.50. By adding an extra 15.50 each time, we can fill out the table. If we have time, we can go and do that work individually, showing our workings out. In part H, we're asked which plan do we think Lisa should choose. She's choosing between Plan A and Plan B, so we place them side by side just to make a comparison between them. There's a couple of ways we can answer this question. Firstly, if we assume, as in part F, that Lisa uses 650 units of electricity, we already calculated that in Plan A this would cost her 137 euros, and if we calculate the cost for this in Plan B by multiplying 650 by the cost per extra unit, which is 0.155 cents, and then adding the standing charge, which is 36, we can see that the cost for 650 units on Plan B is 136.75. So in this scenario, Plan B offers a saving of 25 cents. The other way we could have looked at the question was to make a judgment on how much electricity she was going to use. If she's going to use a low amount of electricity, then Plan A has a lower standing charge and therefore is the way to go. If she's going to use a lot of electricity, then she's better off with Plan B, which has a higher initial standing charge but a lower cost of electricity per unit used. And so for high amounts of electricity, Plan B ends up being cheaper. In part I, we're now asked to draw the graph showing the relationship between the number of units used and the cost of electricity for Plan B. Again, this is a linear function, and so it's sufficient to just draw 2 points on the graph. So if we take the lowest point when 0 amount of electricity is used, there's a standing charge of 36. And so if we start at 0 units used and work our way up 10, 20, 30, 40, and go a little more than halfway between 30 and 40, we get to 36 units. And for the other point, we'll use the other extremity of the line, 800 units used and a cost of 160. So we go to 800 and we work our way up to 160, which is 10 past the 150 marker. We place a dot, and then to graph the function for the cost of electricity for plan B, we draw a straight line connecting the two dots. The final part of the question asks us to use our diagram to find the number of units for which both plans will have the same cost. So we're going to find the point of intersection of the two graphs, and then from that point, draw a vertical line down until we reach the number of units used, which we can estimate to be 640 units. We could check this answer algebraically by letting the two functions for the cost equal each other. It's not necessary to do this in the question, as it does say use your diagram, but it will help us get an exact value for what this unit should be. So if we let 20 plus 0.18x, the cost for plan A, equal 36 plus 0.155x, the cost for plan B, and try and solve for the value of x that satisfies this equation. If we collect the x terms on the left, we subtract 0.155x from both sides. And if we collect the number terms on the right, we're going to subtract 20 from both sides. This gives us 0.025x equals 16. We divide both sides by 0.025, and we get that x is equal to 640. So at 640 units, both plans have the exact same cost.